our chapter 6 for algebra. So you know what comes after this? We're going to start reviewing and having a test over this unit. So be sure you understand this last new chapter, and it's actually, or new lesson, it's actually a really short one too. It's only a front side, so let's check it out. It is Systems of Linear Inequalities. So yesterday on 6.5 we only did one linear inequality, and today we're moving up to systems of linear inequalities. And we know because of earlier in the chapter that systems means there is more than one. So we're going to have some interesting time graphing and shading when we're talking about boundaries of two different lines. So we'll get to that in a minute. Here we go. A system of linear inequalities is made up of two or more linear inequalities. For our Algebra 1 purposes, we will just be using two. A solution to the system of linear inequalities is an ordered pair that makes all of the inequalities in that system true. So it will have to work on both the correct shaded sides of each line. Okay, the graph of a system of linear inequalities is the set of points that represent all of the solutions of the system. Okay, let's just try it. What would the graph look like? So let's graph this first line first, and I am going to put my first dot at -3, and I'm going to count slope, which is 2 over hidden invisible 1, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I'm going to go back down 2 over 1, and I'm not going to draw in the line yet because I first want to see if it's supposed to be solid or dashed. And I look, and it's only less than. It's not less than or equal to. So therefore, it is going to make a dashed line, because that is showing us that one of the solutions is not on the boundary line itself. It is only going to be above it or below it. Okay, let's move on and graph this other one, and I am going to do it in a different color, and I'm going to hate it already because we can't graph it because it's not in slope-intercept form. So just like you would if this was an equals, we are going to minus that 2x, subtract it to the other side so that we can get y by itself, making it slope-intercept form. So y is not equal, though, it's greater, I'm going to bring down that symbol with it, than -2x plus 2. Okay, now I can graph it. So put a dot on your +2 on the y-axis. Slope is -2, which is down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. I'm going to go back the other direction and go up 2 over 1. And I'm not going to draw my line through it yet because I need to see if it's solid or dashed. And it is not or equal to, so this one is also dashed. What you might notice that's different than earlier in the chapter when we were graphing is these where they intersected would have met at an exact point. And even though they do, even though it's not a great point, it doesn't matter on these because we're just going to be shading the solutions. We're not going to be finding one solution. We're finding all the things that are less than this and greater than this. So in order to find them, we need to shade both. So I'm going to go back to my original purple color, and I'm going to determine which side of that line first I should shade. You know, it's up to you. It's a preference, but some people probably graph their first line and then go ahead and shade it, and then graph their second line and then go ahead and shade it. So maybe I should have done that. I don't know. So let's look at this first one. Forget the light pink color. I'm only looking at this line. I want to shade representing the solutions that y is less than the stuff. So here's the line, here's the y-axis. Would less be below or above on the y-axis? I hope you know that less than is below. So I am going to shade very lightly below my purple line. And the reason, I know you can't really shade lightly with a marker, but the reason I'm not shading it in super dark is because I still need to be able to see my pink line, because now I'm going to go get the pink and see which, like the right or the left, the above or the below of this one I'm going to shade. So this one says y is greater. So let's go to my y-intercept. It crosses right here. Greater is going to be above the line. Less than would be below. So I need to shade above because it's greater. So I'm going to shade in lightly the entire area above my line. And look at what has happened. We have this area that has been double shaded. In fact, I'm going to darken it in now because now that I know which of the 4 regions it's going to be, I know that this is the only solution set. And the reason that these are the solutions is because these are the solutions that work for both inequalities. Okay, this light pink only works for this one, and this light purple only works for this one, and this doesn't work for either one. But this side that is darkened in, it's completely shaded, works for both. It is a solution. All of these would be a solution to both this inequality and this one. So that is basically my answer. Okay, if you just have a pencil, just make sure it's like lighter here and then darker here, because we definitely want a clear division of the actual solutions versus the ones that are only solution to one or the other. Okay, go back to starting with purple. Let's graph this one. First dot on 5. Next dot is, it's a -1 slope, so it's down 1 over 1. So -1 slope goes down 1 over 1. And don't draw your line until you know if it's solid or dashed. This one is greater than or equal to, so it is solid because the boundary line, that means, is part of the solutions. Okay. I'm just going to do it the same way I did the other one. I'm going to go ahead and graph my other line. Nope, I can't because it's not in slope-intercept form, but it almost is. All we have to do is add 3x to both sides, and y is by itself. So y is less than or equal to 3x minus 4. So my first dot is going to be on the y-axis at -4. I'm going to count up 3 over 1 because my slope is 3. Up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, and my line is solid again because it is or equal to. So a solid line through those dots. All right, now let's see which sides to shade. So I'm going to go to my y-intercept on my purple line, which is way up here. And it's y is greater. So is greater going to be above or below? If I'm going bigger numbers, I'm going greater, I'm going up. So this half plane is shaded. And I'm kind of out of space up here. So I'm just going to shade it lightly, as light as I can with my marker over here. Okay. The pink line says y is less than or equal. So go to my y-intercept, it's right down here, less than. Less than is going to be below it. These numbers get less than as you get bigger negatives. Okay, greater would be getting bigger numbers. So less than is going to be down here. So this whole half plane on this kind of right side, because it's below, is going to be shaded. So I'm going to lightly do this. And then when I get to the area up here, I'm going to go ahead and darken it in, because this is the area that overlaps both lines. Therefore, it would be solutions to both inequalities. Okay, now you guys get to write the inequalities for a graph that's already there. Okay, here we go. So we're going to start with, it doesn't matter, we'll start with this solid line right here. Okay, so we're going to start with y. It is shaded, it's hard to see, but it's shaded darker above the line. So bigger than the solid line. It's shaded greater. So I want to write greater. And this line that I'm talking about is solid. So it is going to be or equal to. Okay, let's go to what the y-intercept is. It is right down here at -1. So I'm going to write -1 because that's my y-intercept. Don't forget x is next to the slope. And now let's see what that slope is. It looks like it's going up 1 over 1, up 1 over 1, up 1 over 1. So the slope is 1, which is hidden. You can leave it hidden and visible. So actually I didn't really need that space. So I'm going to write it a little bit closer together and forget about this. Okay. So one of my lines, my solid line, is y is greater than or equal to x minus 1. Okay, now let's do this dashed and negative. See how it's going downhill? Negative line. So this line is y is, and it's really hard to see where it's shaded, but I think the double shaded region is this one right here. So it's y is going to be shaded more below this line. So it's going to be less. Below means less because the numbers are getting smaller. So less than, and it's not or equal to because it's dashed. Okay, my y-intercept is right here at 1, 2, 3, 4, 5. So it's going to be plus 5. Whatever my slope is has an x next to it. And let's see what my slope is. It's definitely negative. It's going down. Down 1 over 2. Maybe. Check it. Down 1 over 2. Yes. Down 1 over 2. Yes. So negative 1 over 2. That is really hard to see. But, in fact, I'm going to rewrite that one too. Y is less than negative half x plus 5. Okay. All right. There's my two inequalities. Let's try B. So this solid line, I'm going to start with this one, is y. There's the line. It's definitely shaded below it, so it's definitely going to be less than. And it is a solid line, so it's or equal to. The y-intercept is 1, so something x plus 1. And then the slope is up 1 over 2, I think. Up 1 over 2. Yes, so it's 1/2. All right. And then the dashed line, I'll do that one next. It is y is, I believe that one's shaded below also. This area up here looks like it's unshaded. So y is less because it's definitely shaded less than this line below it. So less than, and it's not or equal to because it's dashed. My y-intercept again, they meet right there at plus 1. And my slope, this time is going downhill. It's going down 1 over 2. Down 1 over 2. Yes, so negative 1/2. Okay. There are a couple of U-tries at the bottom. This is a really good time to pause the video and actually try these last two problems on your own. But if you're not quite ready, I will work it out with you right now. So I'm going to graph this first line. I'm going to put my first dot at negative 2. I'm going to count slope, which is up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. I'm going to go back down 3 over 1 if that fits. Yes, it does. And it is going to be a dashed line because it is not or equal to. So we are going to try really hard. Well, it's a little squiggly. Make it as straight as you can. Sorry about that. Okay, I'm going to go ahead and graph my other line, and unfortunately it's not in slope-intercept form, and it's really not even close. So I'm going to use the space over here to rework this so that it can be in slope-intercept form. So I'm going to add x to both sides because you really need to leave y where it's at. I just want y to be by itself. So the last step then would be to divide by 2. Just be careful when you divide both sides by 2 because here's what happens. This is a hidden invisible 1 here. So when you divide this, it's a fraction. We're just going to leave it that fraction 1 over 2. So it looks like 1 over 2x. And then 6 divided by 2 is positive 3. So I'm going to put my first dot at 3 on the y-axis. And then I'm going to go up 1 over 2, up 1 over 2. I don't know why I bullseyed that. That was out of habit. You don't need to do that. It doesn't have anything to do with where they meet. Sorry. Down 1 over 2. Okay, and this is a solid line because it's or equal to. So I'm going to make it a solid line. And now let's go see where to graph. So I'm going to go back to my purple line, which is this one. And I'm only looking at the purple line. If it helps you to cover up the pink line, go ahead and just cover it up. I'm only looking at the purple line. It says y is greater. Y is greater. So I want to shade greater than this line. So greater is going to be above it because these numbers become greater. So I'm going to shade this whole area lightly if I can that is greater than my purple line. Okay, and now I'm going to go shade my pink line. So I'm only trying to look at the pink. The pink line says y is less than or equal. So I want to go to my y-intercept and I want to shade less than. Less than is going to be below the y-intercept, which is here. So I'm going to shade everything below this line. And when I get to the part that was double shaded, I'll make it darker because I definitely want to be clear about what the actual solutions are to both inequalities. And the darkened part is where they both are solutions. Okay, and then our last one, so I'm going to start by doing this solid line right here. Y is, if you look at where the y-intercept is, it's shaded above it. See how it's shaded above where the y-intercept is? So that, it looks like it's to the left, but it's actually, look at the y-intercept, it's above it, so it's greater, and it is a solid line, so it's or equal to. And my y-intercept is 1, 2, 3, so something x plus 3, and the something is my slope, which the slope looks like it's going up 1, 2, 3 over 1. Let's make sure that's right. 1, 2. 1, 2, 3 over 1, 1, 2, 3. Yeah, 3 over 1 is 3. Okay, so y is greater than or equal to 3x plus 3. And then let's go to the dashed line over here. So this one is y is, if you go to the y-intercept, it looks like it's shaded below it. So see how it's shaded underneath that part? So it is below, which is less. Less than is going to be going down. So less than, and it's not or equal to because it's dashed. My y-intercept is right here at -2. And the slope has an x on it. Don't forget your x. A lot of people forget the x. The slope is negative. It's going downhill. And how many is it going downhill? 1 over 1? Looks like it's going 1 over 1. Down 1 over 1. So -1 over 1. Actually, we don't ever write the 1. It's kind of, it just stays invisible. So I'm going to rewrite this one, -x minus 2. And that means -1. There's that one. And here is this one. Okay.